We're going to finish parametrics today. I also have a review worksheet to do. Does anyone want me to post that on Canvas? You like to do it on your iPad? Or I printed them out.
No.
We'll do a printout? Because I can. It's easy. I have a PDF of it I can post. Or maybe I already did. I don't know. All right, we're going to do absolute value.
Yes.
Absolute value and parabolas. So for our parametrics, we've already done circles, ellipses, lines, and now we're going to do absolute value and parabolas. I know, right? Yeah, circles and ellipses are usually the harder ones, but I like to start with those because, you know, you can make a line with any function, so I want to do something more interesting. Hyperbolas, you can, but we don't really focus on those. All right, number 1. Here we go. Suppose that you have x equals 5 plus the absolute value of t, and then y equals t minus 3.
Is that a plus in between?
Yeah. What do you think that is, Trevor? That's totally a plus.
I was just saying another t, to be honest.
I just make it smaller.
Better?
Okay.
All right.
T's are curved.
My t's are always curved.
5t absolute value of t.
5 plus the absolute value of t.
5t absolute value. 5t times.
I'm going to kill you. Oh, that's on video. Oops. Threatening. All right, negative 4 is less than or equal to t is less than or equal to 4. Maybe that's why my videos are trash, because it's threatening my children.
Probably talking a lot.
All right, so here we go. We're going to do all the stuff. Okay, we're going to graph it. Well, not all the stuff. We're actually doing some different stuff. So here we go. Let me tell you what we're going to do. First, we're going to graph. So yeah, get your calculators out. You're going to need them. Then the second thing we're going to do is we're going to find the values of t that produce the graph in quadrant 1. Okay, I'll explain that. Quadrant 1 values of t. And then we want to find the value of t at the vertex. Okay, let's do that first. Okay, so get your calculators. Go ahead and graph this. You guys know where the absolute value is on your calculator? Okay, so once you do that, you can now sketch a graph of it. You guys, you can find specific points on here. You can hit the trace button. And if you hit the trace button, you can actually plug in values for t. Oh, you need to go to Format, Second, Zoom, and you're in polar coordinates. You need to be in rectangular coordinates. That's from last year. How funny. All right, if you hit trace, you can actually plug in negative 4 and hit enter, and it'll give you that t value. So that way you can actually plot some points. So that t at negative 4 was x is 9 and y is negative 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be that point right there. And then you can just keep following it. Okay, you can plug in t is negative 2 now, get another point. T is 0. Ooh, look at that. That's where the vertex is. T is 0 is at the point. X is 5, y is negative 3. 1, 2, 3, 4, 5. Right there. Okay. I'm going to plug in t is 2. I get another point. Plug in t is 3, and I'm actually on the x-axis at the point 8, 0. And then when t is 4, I'm at the point 9, 1. All right, right there. And so our parametric graph goes like that and like that. Is that a function? No, it's not. But it's really easy to graph parametric graphs that aren't functions. Doesn't pass the vertical line test. And it doesn't keep going. So don't draw arrows on the end of it. It stops because this is t is negative 4 right here. And this is t is positive 4. So I could ask you a couple of things. Well, the question they want here is what values of t give us this graph in quadrant 1? Do you remember which quadrant 1 is?
Yeah.
This is 1, 2, and it goes around the other way, 3, and 4. Okay? So what values of t do I get for my points that are all in quadrant 1? That would be did we find this one right here? This was when t equals what? Do you remember? T equals 3. So the values of t that produce the graph in quadrant 1 would be, let's see, no, I don't want to do that. T has to be greater than 3, less than or equal to 4. How come 3 doesn't work? Is when t equals 3, is that in quadrant 1? No, it's on the x-axis, which is not in quadrant 1. So I'm greater than 3, but I'm less than or equal to 4, because that's where I stop. So this is my quadrant 1 stuff right there. I could ask you a couple other questions like letter C. What was the initial and terminal points? What's the initial and terminal points of this graph? Well, the initial point is by plugging in t is -4. What was that? 9, -7. Perfect. And the terminal point is by plugging in +4, the nt of the graph, which was?
9, 1.
Perfect. 9, 1.
Why is it 3 not included for the quadrant values?
Because when t equals 3, I get the point on the x-axis, and any point on the x-axis is not in any quadrant. So I need to go just past 3. Like, 3.00001 t could be. All right, and then what was the value of the vertex? What was the t value of the vertex? What is the vertex and what's the t value there? So the vertex is blank when t equals blank. T was 0, and that vertex was at 5, -3. Perfect. Good. There's just questions, and you can use your calculator, and you can do trace and plug in t's and all that stuff. It's really nice, okay? All right, now let's do one more, and then we're going to get to our review worksheet. Let's do the parabola one that I wanted to do, number 2. We're going to find a parameter for the right side of a graph, okay? So find a parameterization, I'm just going to abbreviate that, for the right side only, for the right side of y equals x squared minus 4x. Find a parameterization for the right side of y equals x squared minus 4x. Now, with parametric equations, there's so many different answers. You know how functions can only be like, this is the one equation, and that's the one function it goes to. Parametrics, you could have a whole bunch of different answers, and people get the same graph. It's kind of cool. For these, if you want to make it really easy on yourself, and you need to write a parameterization for something, this is the easiest way to do it. You can let x equal t, which means y would equal what if we plug t in? Perfect. T squared minus 4t. That's nice, right? That's easy. Let x equal t, and then y would be t squared minus 4t. But we want only the right side. That's the hard part about this problem. You want just the right side. So let's go ahead. Let's graph the parametric graph that we just came up with. So we'll graph x is t. Yeah, we got to figure that out. So x is t, and y would be t squared minus 4t. Let's do our window from -10 to 10, just to see what that's going to give us. That's going to give us the whole parabola. Oh, shoot. I'm way over there. Why am I way over there? Zoom 6. Zoom 6. Oh, Zoom 6 actually works because you can see where you need the other, just the right side of the parabola. So let me go ahead and draw this. And if you factored this, you'd know that it has zeros at 0 and 4. Did you know that? Maybe, maybe not. And here's the parabola. Now we want only the right side of this parabola.
Vertex is the x.
Yes, so what's the vertex there? And what t value is that at? T is 2? So you could trace and plug in like t is 0, I'm up there, t is 1, not quite, t is 2. Ah, t is 2, there it is. At t equals 2, we get the point 2, -4, which is the vertex. So I'm going to tell you that my restrictions on my graph here, because I only want the right side, t has to be greater than or equal to 2. Okay, now go to your graph and try it. Do the window And do 2 pi if you want to, 2 to 10. Okay, and graph, and you only get the right side of the parabola. Okay, but you have to find that, what that is, and that was t equals 2. Your calculators will really do a good job on that too. Ooh, I've never done that. Have you ever tried to, you're like, no? Have you ever tried to do, calculate the minimum of this? It won't.
I looked it up.
Nuh-uh. It calculates the value, dy, dx, the stuff we're going to do, derivatives.